And now for the final part of our look at the solar system. Now we will discuss Jupiter, Saturn, Uranus, and Neptune, and then compare what we've learned about the planets in our solar system. Jupiter and Saturn are very large gaseous worlds. Jupiter is located 5 AU from the Sun, meaning 5 times as far as we are. Saturn, on the other hand, is almost twice as far as that, at 9.5 AU from the Sun. Though Jupiter and Saturn are both around 10 times the Earth's diameter, give or take a little, they are hundreds of times the mass of Earth. If they were comprised of the same materials as the Earth, they would be even more massive. When you look at Jupiter, you notice dark and light bands. These can be seen in even a modest telescope. And if you could take time-lapse photography, you could see the bands rotating as time went on. Saturn also has bands, but they are not as distinct as that of Jupiter's. It has a similar composition to Jupiter, mostly hydrogen and helium. This is what a cutout of the interiors of the two worlds is thought to look like. At the very center, you have a rock and iron core. Surrounding that is water and liquid hydrogen, and then gas in the form of molecular hydrogen. Here are some facts about the interiors of Jupiter and Saturn. These worlds experience what is known as differential rotation, meaning that the speed that the planet rotates at the equator is not the same as the speed that it rotates closer to the poles. This differential rotation has the effect of creating tremendous winds. These are also due to the Coriolis forces on the gas itself. The Great Red Spot, which is a distinct feature on Jupiter, is a huge vortex. The wind speeds there are around 500 kilometers per hour, which is extraordinarily fast. And it is a very long-lived storm. It has been around for at least 300 years. Galileo noted its existence when he observed Jupiter. Saturn has storms as well, although they are harder to pick out than those on Jupiter. They still have very high wind speeds, even higher than some on Jupiter. The reason they are less apparent, it is thought, is because the storms take place deeper into the atmosphere. Both Jupiter and Saturn have magnetic fields. Recall that for a planet to have a magnetic field, it generally needs some kind of metallic core and rotation. Jupiter and Saturn have both of these, with a metallic hydrogen core and rotating fairly rapidly. This generates enormous magnetic fields. Jupiter's is 20,000 times as strong as the Earth's. And Saturn's, though smaller than Jupiter's, is still 500 times that of Earth's. Just as we experience northern lights or auroras, Jupiter and Saturn experience the same thing, which is charged particles getting trapped in the magnetic field near the poles. Let's move on and look at Uranus and Neptune. Uranus was discovered in 1781 by William Herschel. It was originally named after King George III, but it was renamed to Uranus to keep consistent with the mythological names of the other planets. Not long after its discovery, it was noted that Uranus was not actually following its calculated orbit. Eventually, astronomers looked to try to find a planet which could be affecting Uranus gravitationally. And eventually they discovered Neptune. It's interesting to note that Galileo actually saw Neptune, but did not realize at the time what he was looking at. Similar to Jupiter and Saturn, Uranus and Neptune are comprised mainly of hydrogen and helium. However, they also have methane, which gives them their bluish cast. These planets are so far from the Sun that they are extremely cold. And like Jupiter and Saturn, they are not very dense. It is thought that they have a core of rock similar to that of Jupiter and Saturn. There are storms on Neptune. Neptune has a feature called the Great Dark Spot, which reminds us of the Great Red Spot on Jupiter. However, it is less noticeable. Uranus is actually tilted somewhat on its side compared to the other planets in our solar system, meaning that its axis of rotation is almost in line with the plane in which it orbits. So it is appearing to be tipped almost 90 degrees from that of the other planets. Perhaps a collision is responsible for this tilt. What's interesting about this particular orientation is that due to the way it is rotating, one hemisphere experiences uninterrupted daylight for about half of Uranus's orbit. And Uranus's orbit is many years long in Earth years. So for years at a time, it is daylight on a particular part of Uranus, while the other hemisphere is in darkness. Uranus and Neptune also have magnetic fields stronger than Earth's. They're not really centered and a little bit tipped in odd directions, but they exist nonetheless. This unit is a little bit of a misnomer. It is called Comparative Planetology. But in reality, it should be called Comparative Planetology of our solar system. To truly compare planets, we really need to look at the hundreds and hundreds of known planets outside of our solar system in order to discern any kind of pattern. However, it is interesting to compare the planets of our solar system and different features that they exhibit. The terrestrial planets and our moon are various sizes and masses. Some have atmospheres, some have very little in the way of an atmosphere. The interiors generally have rock and an iron and nickel core. But the size of these various parts of the interiors is a little bit different for each planet. The surface temperatures vary widely. From Venus at 750 K to the cold side of Mercury, which is only 80 K, and temperatures in between. Biological processes actually shape the surface of our world. And water has a role too to play. Note the bullet point at the bottom of the left-hand column says too little CO2 can lead to cooling Mars. This has to do with the extent of the atmosphere rather than the percentage of carbon dioxide in the atmosphere. As we saw, is 95% carbon dioxide. It's just that the atmosphere is very thin. How much sunlight a planet receives also has an impact on its surface temperature. The larger giant planets are, reasonably speaking, colder than the terrestrial worlds. This makes sense, because they are farther from the sun. These planets have no surface that you could step out onto, being comprised of lots of gas and a very thick atmosphere. The giant planets also exhibit something called an equatorial bulge, whereby the differential rotation causes the equator to bulge out and be wider than the radius from north to south. Though this is also the case with Earth having a wider equatorial radius than north-south radius, it is not as dramatic as on the gas giant planets. Again, this phenomenon is called an equatorial bulge. All the giant planets actually have a ring system. It's just that Saturn's is most obvious to see. Even with a modest telescope, you can pick out the rings around Saturn. But there are thin rings around Jupiter, Uranus, and Neptune as well. And all of these planets have many moons, Some of them are likely captured asteroids or trans-Neptunian objects, and others seem to be moons in the more traditional sense of the word. The gas giant planets are colorful. This has to do with their different composition. Though all of them are composed mostly of hydrogen and a little helium, Uranus and Neptune also contain methane, which adds a bluish cast to their color.